All right, so let's finish out this lesson with the idea of adding and subtracting polynomials. And that's what this lesson is about. We want to be able to add and subtract these series of terms. Now, it does kind of point out some interest for information for us is that when we're dealing with polynomials, it's said it's closed, which means it works with addition and subtraction. But our answer, whether we're adding or subtracting, that's sum or difference of two polynomials, is also still going to be a polynomial. Just as if you were to add two integers, a 5 and a 2, it gives you an integer known as 7. But the idea is really simply this: combine the like terms. This adding and subtracting is just simply a combining of like terms. They have to be the same type of term in order to actually go together. So let's look at an example. It says add the two polynomials. So I have the first one, which is 2x, and I'm adding a second one, which is 5x. Now we've done stuff like this before. 2x and 5x, even though individually they're very small, we know that we're just going to combine as long as they're the same term. And yes, they are. We know that they're the same term because they both have the same power, which is a 1, because it wasn't written in either cases. If one of these was a squared, they would not combine. So since they are both a power of 1, we would combine them and we'd say, oh, okay, well, 2 plus 5 is 7. So we have 7x for our answer. Let's try it again. Add the two polynomials. Well, again, we have to combine the like terms. That's what this adding and subtracting is all about. They have to be the same type of terms. Well, notice that this first one is a 3x squared, and the second one is a 1x squared. We don't write the 1, but there is a 1 in front of that. It's a 1x squared. But this 4 doesn't have an x squared with it, which means we would not be adding it to any of these others when we go to combine them. It has to stay on its own. So instead, we end up with this 3 and the 1 combining, which of course is going to be a 4x squared. And then we would just say plus 4. And that is our final answer. That's as far as we can combine things together. And notice that we combined 1, 2, 3 individual terms, and we got them down to just 2. So this is a binomial, a trinomial down to a binomial when we combined terms together. This works the same way with subtracting. We just now have to look at the signs. So let's try it with subtraction. Again, it can only combine through addition and subtraction when the terms are the same. So I have a 7x minus a 14x. All right, well, those are the same type of terms. Again, this 3 on the end, this minus 3, it doesn't have an x with it, so it can't combine with either of these other two. But a 7x minus 14x, think about it in terms of dollars. You have $7, but you spent 14. Oh, well, you're not walking away with the item. Instead, you will still owe $7. And in this case, we will have a minus 7x. And then we have a minus 3 because, well, the 3 and the negative 7x do not combine together. So let's carry this a little bit further. Let's expand. But the idea will still be exactly the same. Let's say we have an x cubed. Well, recall that if the degree is different, they are not the same kind of terms. So that means this negative 6x cubed and this negative 4x squared, they're two different terms. You might think of this x cubed as pineapples and the x squared as rocket ships. They don't go together. But I do have an x cubed back here, which means it would combine with the other x cubed. And we'd say, okay, well, negative 6x cubed plus 2x cubed. Okay, we can kind of just do this vertically or horizontally, however you want to look at it. Negative 6 plus 2 means that we're at a negative 4x cubed. And we could not do anything with the negative 4x squared. There was no other x squared terms. So in that case, we are done. So let's expand upon this a little bit further. Let's kind of group things together. Let's have larger portions. It won't matter how big we go with the portions. And I decided to change the portions with parentheses. I have this whole group here plus another whole group. It doesn't change the mathematics. We are still combining the same things. I like that idea of lining it up. So I'm going to write the second one because it's a plus and a plus sign. I'm going to add it. But I need to make sure I line it up correctly. For instance, this is a 2x cubed. If I have an x cubed in the second one, which I do, it needs to go below the x cubed. So I took care of that one. Then I have an x squared. Do I have another x squared? I do. So I'm going to put that plus, and it's still a plus, 2x squared. Then I have an x. Well, the second one doesn't have an x. It has rather a negative 1. And of course, we know they don't go together. So in the end, I will just have a minus 1 here at the end. So then I do it vertically. 2x cubed plus, well, this is a 1x cubed. So that would be a total of 3x cubed. Negative 5x squared plus a 2x squared. Well, negative 5 plus 2 is a negative 3x squared. Now watch here. I have an x plus, well, nothing else. So I have 1x plus nothing else. Well, that means I still have 1x. And then I have nothing in terms of constants plus a negative 1. So I still then just have a minus 1. You can only combine the pieces that go together. Let's try it again. I have 3x squared. Do I have, and I have a plus sign, so nothing here changes, but other than I have to look to see if I have any other x squareds. And I actually kind of like to do this method. Maybe I'll do this method. I highlight the terms that are the same. In that case, 3x squared plus 1x squared. 3 pineapples plus 1 more pineapple is a total of 4x squared, or 4 pineapples. Let's change the color of the highlighter. I have a single x with a degree power of 1. It's not written, but it has a degree power or power exponent of 1. Do I have another single x? Well, I do, right there. So I will highlight that one. Positive x, 1x plus 4 more x's is a total of 5 x's. Then I have a negative 6, so a constant term and a constant term. Those will now combined. Negative 6 and positive 10, well, that's the same as 4 plus 4. And now I've used up all of the terms. And so I have combined the things. I have added 2 polynomials together, like we did on all the previous problems. What though if it's a subtraction? Well, it doesn't change the process other than the fact that this negative it's multiplying. It's multiplying negative 1 times all of this stuff back here. Just as the parenthesis up here has a 1 times 4n squared would give us 4n squared, and 1 times 5 would be 5. I instead here have this negative, this minus, which means I need to distribute this -1 to all of these other things. I multiply it all the way out. So -1 times -2 would be a positive. Negative times a negative is a positive. So I end up with positive 2n squared. So I can write positive 2n squared. But what about -1 times positive 2n? Well, that would be a positive times a negative is a negative 2n. So I end up with negative 2n. And last but not least, a -1 times a -4. Negative times a negative is a positive. So I end up with 1 times 4, which is positive 4. So the only difference between the adding two polynomials and subtracting is if there's a subtracting, you've got to distribute. And notice that every one of the signs got changed. That's what a negative does when you subtract. And now we go about combining the pieces that are the same. I have a n squared and an n squared. They'll go together. 4n squared and 2n squared is a 6n squared. I have a constant 5 and a constant 4. 5 and 4 make 9. I'm going to write it at the end because we typically write the constants last. You've learned from the previous lessons that that's what happens. Then the only term left is this -2n. Why didn't it combine with these others? Well, because these others were squared, and this is only an n with the first power. We don't write that power, but it's n to the first power. So it doesn't combine with the others. So instead, I end up with a -2n. And now I've used up all of my terms. I've combined them all together. Let's try it one last time. Again, I have a subtraction of two polynomials. I have a first one and then minus a second one. So I need to start by distributing. There's nothing in front of this parenthesis than a 1, so I'm just going to get 1 times all of this. 1 times 4x squared is 4x squared. 1 times -3x is, well, a -3x. And 1 times 5 is 5. But what happens back here? Well, it's got a -1. -1. Well, -1 times 3 is a -3x squared. Negative times a negative, that is going to change to a positive x, a plus x. And a negative times another negative, that's going to change to a positive 8. And now I combine the terms that go together. I have an x squared and another x squared. Look at the signs. This is 4x squared and a -3x. Well, 4 minus 3 is really a 1. I could say 1x squared, but we don't typically write a 1, so it doesn't have to be there. Then the next thing is a single x. X to the power of 1. So -3x and, oh look, a positive x. So what is -3 and a positive 1? Well, that would come out as a -2x. And last but not least, what about a 5 and an 8? Well, 5 plus 8 is 13. Again, why did these two not combine? Well, this first one was a squared, and the second one is only to the first power. They have to have the exact same exponent size in order to add together. You are simply combining like terms. So to add and subtract polynomials, the key idea, combined like terms. And if it has a negative, like we did in the last two problems, it just distributes. parentheses mean to distribute.